SVD for word representation. Similar value decomposition, commonly called as SVD, is a mathematical technique used to reduce the dimensionalities of the word context matrix. In a natural language processing, SVD can use it to convert a larger and a word context representation into a smaller, denser word vector. Now, let me explain. In count-based word representation, we create a word context matrix where the row represents the words and the column represents the surrounding context words. When the vocabulary is larger, this matrix can contain a very larger number of dimensions. SVD help us to reduce these dimensions while preserving them the most important information about the relationships between the words. The basic SVD decompositions of the matrix A is A equals to the ordinary word context matrix. U represents the matrix containing the word related information, whereas the sigma, the diagonal matrix containing a singular values, with the V transpose of the context matrix. The singular values indicates how important a different dimensions are. Rank K approximation. Instead of using all the dimensions of original matrix, we can keep only the K largest singular values. This is called as a rank K. So why we do use the SVD? Suppose a word context matrix contains 1,000 number of dimensions. Working with all these dimensions can be an expensive and insufficient. SVD allows us to represent the each word using much smaller number of dimensions. For example, instead of representing a word using 1,000 dimensions, we can also represent it using 100 dimensions. These lower dimension vectors can be used to calculate the similarity between the words. Now, what is meant by our word similarities? After obtaining the reduced word vectors, we can use a cosine similarity to determine how similar the two words are. A value closer to the 1 indicates that the vectors are pointing to the similar directions, meaning the corresponding words have a more similar representations. Reduces the dimensions of the word representation, removes some noise from the original matrix, making a mathematical operations more efficient. So, SVD is an important dimensional reduction technique for count-based word representation. It decomposes a larger word context matrix into a smaller matrix, and that allows us to keep only the most important dimensions. That produces the compact and the word vectors that can be used to take a risk such as a word similarities and cinematic analysis.